So let's jump into chapter 6.2 and talk about the types of sedimentary rocks. So by the end of this section, you should be able to explain how clastic rocks form, be able to contrast coarse, medium, and fine-grained rocks, and then also be able to explain how chemical and biochemical, aka organic rocks, form. So there are three main types of sedimentary rocks. You have clastic, chemical, and biochemical. And then we can also break clastic down into coarse, medium, and fine grains. So first we can look at clastic rocks, and these are the most common types of rock, and clastic just means broken. So essentially they're made up of loose particles of sediment. So if we look at coarse grain, a coarse grain rock is a sedimentary rock that has gravel-sized fragments in it, gravel-sized sediment, and this would be known as coarse. So again, if you think back to minerals, coarse grain were those larger grains that were a lot easier to see. So within coarse grain, we can break it up into conglomerate, and these are sedimentary rocks that have more rounded particles, which if you think back to last section means that they've traveled a lot more, they've been worn down over time. And then breccia, and these are more angular. So these haven't had a chance to be broken down or are made of harder minerals that resist that breaking down. And if we jump back to the last slide, you could see examples. The conglomerate, all the sediment within it are a lot more rounded, whereas in breccia they're very angled and therefore have not been broken down as much. We then have medium-grained rocks, and these are rocks that have sand-sized grains, and these usually have a very high porosity. So porosity is just the amount of space between each grain in the rocks. So if a rock is more porous, that means there's more space, and that means water can travel through the rock easier, or even air can travel through the rock easier. So these pores are what allow the flow of water. So if you have a foundation of a house, you have to think about when you're pouring that foundation, what type of concrete are you using, and is it porous or not? Because you need to think about, is water going to be able to get in or not? And then you have fine grain, and these are the rocks that have very, very small grains, so along the lines of silt and clay. So a lot of times you're going to get these sedimentary rocks to form in swamps, ponds, and deep oceans where you're going to get a lot of sediment that doesn't move often. So this is forming from very, very small, very fine sediment and material. So those all fell under clastic rocks, and again, clastic rock is just that loose sediment. But then we have chemical rocks. So if we think back again to minerals, what happens is when you have a concentration of dissolved minerals in a solution that's supersaturated, you're going to get those chemicals to start to crystallize and settle out to the bottom. So what can happen is you can get a layer of chemical sediment to build up in an area if this process is happening enough, and this leads to something called evaporites. So these chemical rocks are essentially just made of the buildup of chemical sediment, or evaporites. And our last type of sedimentary rock, besides clastic and chemical, is biochemical, or organic rock, and this means that it's rock that's formed from the remains of once living organisms. So some common examples are limestone, which is made of calcite, and if you look at the cliffs of Dover down here in England, these are all made from calcite. And so this is essentially the broken down version of shells and organic material from, again, once living organisms. So these are also the rocks that are often going to contain the most amount of fossils. So now that we've gone through this section, make sure that you know how those clastic rocks form, be able to contrast coarse, medium, and fine-grained rocks, and then also explain how those chemical and biochemical rocks form. Until next time, have a good one.